Okay, so thank you very much for coming back. So now we are starting with breakout sessions. But before we start with this part, we'll have a few short talks, so kind of impulse talks. But we'll have more groups than those talks which we have there. So this part of the program was prepared mainly from Marie-Louise Lechner, but like I said, she's with fever today in bed, so I'm kind of back up, and I'm sure I will forget something, but so we'll start now first with these short talks, and the first speaker is Jürgen Cito. He has no slides, but yeah.
All right. Good morning, everybody. Thank you so much for Professor Mira Mazzini for the wonderful keynote today. As it happens to be, I'm in the same field of research as Mira. I work on software engineering. I'm a professor here at TU Wien. And I took the impulse pitch very literally. I thought, okay, I'm going to get impulses from today's keynote, and then I'm going to generate a speech, right? So this is where it is. Okay. So I am very similarly as Mira in the field of program analysis, classically, which is, if I want to say it very bluntly, the field of taking in a program, some piece of software code, and outputting some kind of prediction about what the code will do in the future, right? In many ways or forms. My PhD, for instance, was about neurosymbolic methods of predicting the performance of software. Okay? So if we connect this to today's AI, I want to talk about three things that, as I was listening to the keynote and just questions from the audience, thought about. So the first thing is guided evolution. So we entered kind of the agentic AI era, and it didn't stop with software engineering. I feel, especially with software engineering, we have opportunities when it comes to agentic AI. Specifically in the field of program analysis. Because what program analysis can give us is formalized signals of how we can improve over time. Okay? So let's think to how you use AI, and maybe some of you have used AI for software development in some shape or form. I think as we usually start with this promise of natural language. You know, we start with, I want to have this app. I want to have an app that tracks my calories, right? You know, and then as something is generated for you, usually it's not quite the right thing in one way or the other, right? Sometimes it's not quite the right interface you envisioned and so on. That is natural because natural language is ambiguous in its form. Okay, so what you do is you evolve and evolve, but that is not scalable in all aspects of computing, right? So some aspects of computing are just not expressible with natural language. Some of them are only expressible with formal languages sometimes. And this is where the field of symbolic methods or neurosymbolic methods come in, right? So I think when I say guided evolution, what I think is we as humans, in one shape or form, need to provide a formal or semi-formal signal to the AI on how to evolve the systems that we need to. That is one part. Yeah? The second part I want to talk about is diffused authorship or responsibility. Yeah? As we are building systems and providing, very small prompts sometimes to build very large systems. In the very recent past, I provided a very small prompt and generated 10,000 lines of code. Yeah? And that is all great and good. But if we make it easy for ourselves as entities that allow these systems to happen, and especially organizations that have responsibility, we can put the responsibility at this one person that with one prompt generated 10,000 lines of code. Okay? Reasonably, one person, and even a reviewer that is maybe assigned, will not be able to review all these 10,000 lines of code by hand. So what do we do in terms of responsibility and authorship, and ownership of this code? I think as researchers, we need to think about methods, techniques, and tools in order to provide abstractions that help users understand what they're actually building and what the impact is to the code they're writing. Thinking back of the keynote, for instance, secure coding. And secondly, as institutions and systems and organizations, we need to think about how we, as we're giving the power of these tools into people's hands and then pressuring them, in the power dynamics that we have to build and grow faster. We need 1 minute? Perfect. Okay, I'm almost done. Okay. We need to think about how we extract that that ownership, basically, and diffuse that power play a little bit. You know, that's the second thing, kind of looking at it from a humanistic way. The third thing that I want to say in 30 seconds is the evolution of education in the face of this. I don't have real answers, and there was a really good question earlier of how education should evolve. The one thing that I want to continue as an educator at the university level, what I do is a flipped classroom style where people learn the theory at home and then they come to the classroom to see me fail, right? So what I usually do is I live code for people, and the best response I've gotten from students around this: professor goes into classroom, fails, you know, and recovers. I think we have to just show what is possible with these tools, where we can guide them, how they fail, and how we can recover. So if you're interested in all these topics, yeah, both from a research but also from an industry perspective, I'm going to lead one of the breakout groups, and it's going to be over there. So thank you very much.
Yeah, thank you very much, Jürgen. So Jürgen is a new professor, full professor of software engineering here at TU Wien. He just had his inauguration lecture, I think, a week ago, or 2 weeks ago. So the next talk will be given from Alexander Czech. He is a co-founder of AI Baseline. So please.
It's the correct one. Cool. So yeah, thanks for the introduction. We at AI Baseline, we are building a retrieval infrastructure for AI systems. Why do we need this? Because like current retrieval infrastructure, if you look at search, is very much built for humans. Like you get a list of somehow ranked elements and you click on them and you read them, you learn something about it, and then maybe you refine your search. And if you look at AI systems, they can either use a very simplistic approach, which is like, I get like a list of ranked elements and I read all of them and then I try to answer a query based on the human question. But vector similarity and like only like the top X results is like usually not enough to like answer really complex questions about complex corporas of text. What we so far came up with is like this agentic loop, or like in trade terms, deep research, where basically you have an AI system that mimics the research loop that a human does, right? It gets results, it reads something, it generates new leads, and then like it searches again. And it repeats and repeats this loop. Oh, I see the icons are not there. Well, anyway, this has like a couple of like issues. One is it's quite slow. Like for computational purposes, it can go up to like 60 or 90 minutes, like depending on how much compute you want to throw at this problem and also how large your corpora is you want to search. It's quite costly. I just said like lots of compute, and it's like either lots of money, CO2 or energy, whatever you want to measure. It can be quite inconsistent because you always rely on the AI systems to come up with like the correct next queries, and it's not very audible. And on top of all of this, you have to do it every time again you search for something, right? Every time you have like this complex query, you need to repeat this process. So what we are doing is we basically use graphs to map complex corporas into. That means we analyze documents, we extract the information and connecting information out of them, and then rebuild a reusable map of an information space for the AI system to look through. This is great because like now retrieval times are down to seconds. The AI system saves like this regeneration time or this loop time, and you get nice fast results, especially if you want to like run like fleets of agents where like a task that takes an hour is like a huge bottleneck. This works for a human, but like if you have like hundreds of agents in your business, this is not good. So on top of this, because we tightly couple metadata information together with the actual content of the documents, we can use the graph structure, the meta information, but also some semantic similarity tools to retrieve this information. And instead of like retrieving raw documents, you retrieve basically paths through a graph. And these paths are connected basically with the base documents where they originate in. Then still, if you want like a human readable answer, you still need to put this through an LLM to like generate an answer. But this is like only one thing where it can be applied. Obviously, you can also apply it in like longer data pipelines and stuff like this. Because we keep it tied very closely to the source material, the graph becomes very governable and also easily to update. You don't have like huge graph recomputation processes, which is also an important aspect. So we see applications we have like a very broad range of applications. To make it short, it's basically everywhere where like complex questions can be asked on top of a like complex corpus of text. This is us. My co-founder can't be here today because she's also sick. If you want to find out more, visit our website. Thank you.
Yeah, thank you very much. So the company was recommended from AI Factory. I think we have also today a representative from AI Factory, and we'll say a bit more in the last session today for AI Factory. But yeah, we had also some collaboration with AI Factory in this for this symposium. So the third talk will be given from Eleonora Laurenza. She's a postdoc here at TU Wien and came from Bank of Italy, and she will also yes. We'll give a talk about agentic AI. Okay, so let me see where.
Okay. Yeah. How many computer scientists, just to start a presentation? More than you think. Okay. Yes, okay. Thanks for having me today. I want to start from some recent piece of news today. JP Morgan, the European branch of JP Morgan, received a penalty of more than 12 million euro just to have misreport the capital requirements, data on capital requirements. Okay? So essentially the bank for years misreported the risk-weighted assets, making its capital ratios appear much stronger than they actually were. Okay? So a penalty of more than 12 million euro. And same fate for other banks. So why do such failures occur in what it seems to be a very easy task like financial reporting? Well, first of all, because financial reporting is not easy at all. Even if you have, like, for example, JP Morgan has your own artificial intelligence lab with more than 100 people inside, okay? It's not easy at all. Here, we are talking about two specific financial reports, COREP and FINREP. Those of you coming from the financial industry know them very well. And they rely on an overwhelming corpus of regulation, both structured like templates and balance sheet data, and full text descriptions. But what is more important is that this corpus of regulation can be ambiguous, even contradictory. This is for real, okay? That's why this is a very interesting case study for many of us. From the financial sector perspective, this problem is also is often called data quality management. For us, for computer scientists, this problem has a lot of names because actually there are a lot of interesting theoretical problems behind it, and of course also a lot of applied research on top of it. So we are inside a lab, a knowledge graph lab, and we propose to this problem a bilateral agentic approach. Why bilateral? Why agentic? I'm not thinking about user productivity tools like, for example, the ones that we know very well, even the rector uses, we saw. We are talking about real agents, okay? Each of which is specifically devoted and designed for a subtask, like, for example, accessing to structured data, mining the rules for corpus of unstructured data, and so on and so forth. So many agents. But do you remember the part of the uncertainty and the ambiguity, both in regulation and in the data? Because, of course, even the internal data from which the financial sector people bring the outcomes can have problem. Not mentioning the fact that you don't know in advance in which order you should involve which kind of agent. So the most effective way in applying agentification to this kind of processes that are knowledge-intensive processes is through a bilateral approach. This is where bilateral approach comes in action, actually. So with a bilateral reasoner able to reason with logical rules when the process itself is very well defined, and through small and large language models when you need more flexibility and the process itself is not fully specified. Because we want to sustain a number of key properties like those that I put here in the slide. So this is our final solution from a lower level of abstraction. Each agent is developed as a software component with a specific responsibility, specific kind of access to resources and interaction with one another. Then we have an environment specifically designed for these bilateral agents from a software engineering point of view. Third and most important thing, we have a knowledge graph that is able to cope with all these agents and contains the necessary knowledge, that's why the name knowledge graph, contains the necessary knowledge about how they should be invoked, how they should be involved in the process, and how they should interact with one another, so that a lower level of abstraction, the properties are even more, not less, okay? Just to conclude, we show today this business process because I think it can be interesting for many of us, but of course, this approach, this bilateral agentic approach can be also applied to other business processes, like, for example, the one that we faced some years ago with the anti-money laundering, contrasting finance and terrorism domain. Thank you very much.
Thank you very much, Eleonora. So now I'm going to give to you some information about the format of discussion that we'll have. Just a moment. Okay, so you already saw 3 pitches, 3 short presentations. We will have one more, but we decided to have only 3 presentations because of time. So there will be 4 groups, which will be led from Jürgen, Cito, as you saw, then Eleonora, and another group is from Bayern Menzat. Actually, here we have another. And there will be another group from Peter Kness, okay? So regarding the last topic, it's about digital humanism and so on. So most of you know about it, and I think it should be also a very interesting topic to discuss. So we are many here, and we need to divide in groups such that hopefully there is a balance between the groups. Of course, you can decide to go in the group, in the topic you want to go, but if you are more interested in general, then please try to go to the group where there are maybe less participants at the moment, so that we have a good distribution. So if you want to go to the group of Jürgen, Cito, that will take place outside, so you have a great view. Of course, if it's too cold, you can come inside too. Then the group of Peter Kness will be also outside, in other side. And the 2 other groups will be downstairs, I think. So we have Kathleen Jimenez here and Julian Ebner. they will lead you to those rooms, and also if you have any questions, you can ask them there from Service Unit Industry Engagement and Partnerships. Okay, so I think we can start. The only thing is that we are a bit later today, so I would say we come back here at 12:30, and we, sorry? Yeah, maybe 12:45, so that we have enough time. We will not have some wrap up, but there will be a place where we put all the materials which are produced from the discussion, so you can have a look also later on those. So then, thank you, and maybe Jürgen and others can go in their places, and you just go, where you want to go. Thank you. Okay, so before we go for lunch break, so we just have a short presentation for iCAIML poster presentations, because you will have the opportunity then to visit them. But before we go there, I hope you had very nice discussions and exchange of ideas in the breakout sessions. The moderators, I think, brought some, made some pictures and so on, and we'll make them available for all sessions. And we will have another session on afternoon. But before we go for lunch, now I would like to ask Stefan Woltran, who is the head of the iCAIML Doctoral College, to say a few words.
All right, thank you very much. I will be very brief, so that I do not take too much time away. Everyone is waiting for lunch. I see already kind of an informal queue forming over there. So just very briefly, in the center we also have this doctoral school, iCAIML, which stands for Innovative Combinations and Applications of AI and ML. In contrast to many other doctoral schools which are quite focused on a particular topic, ours is super wide. So what we aim for is to try to bring together students from different AI streams, in particular symbolic and sub-symbolic AI, but also the students from the computer science faculty, from the informatics faculty, with the other faculties. So therefore we have, among our 23 students, we have colleagues from the faculty of informatics, but also from the maths faculty, from the physics faculty, and from the chemistry faculty. I mean, I think this is very nice. So since in the center, there's so to say the networking between the professors who have obviously other interests, and now we have this second layer, which I think is even more fruitful, is that we have the students from the different faculties talking to each other, meeting with each other, and exchanging ideas. So this runs very nicely, and you can see some of the outcomes at the posters, which you see at the Windows side, and please feel free to visit them. The students will be there to explain to you what they are doing. And finally, I just wanted to mention two things. Of course, running such a doctoral school is not possible without the help of several people. So I just want to mention Sabine Andergassen as the co-director, and Markus Mayhoff and Alex Beiser, who are kind of organizing the student activities and help us with the webpage and so on and so forth. So thank you very much, and now enjoy your lunch.